Budonaruskom. So I will speak in English for those who understand that. So we talk about the challenges when moving from some other languages to Scala. And you learn the language, the syntax and whatever, and then you say, okay, I know Scala, and then, oh wow, it's not so easy. So the first question, anybody of you did use another language and then moved to Scala or are currently moving to Scala? So what language did you use before Scala? Who used Java before as a, okay? Who used PHP? Ruby? Something else? What? Sorry? Okay. Yeah, so anyway, so it seems to be that the Java is kind of a prototype of what many people came from, and some things that apply to other languages also. So we can just say, okay, it's like this. We just try to map it, and then we use Scala, and we are cool, but we basically try to do the same as we did in Java. And it's possible, and it's maybe a good step if you say, okay, you need somehow to move, and you have people and that want to be productive, and you can just say, okay, we stop working for 1 year, but don't get stuck there. It's not the right way, because Scala has a lot to offer, and just to get operator overloading on top of what Java can is already good, but it's not enough. So we should move to real Scala, and we should try to understand what Scala is meant to be, what is the strong points, and we should do like idiomatic Scala. That's where we want to move. And so there's some question. The first thing that we might get struggling is the type system, yeah? So in Java, we kind of understood it was like more or less dynamic typed or untyped. You had like the collections that were all object, and most of the time you use collections. So basically the old Java was mostly dynamically typed only, and then you added these generics, and it was like some places it worked, some places not. But in Scala, we kind of have this type system. It's very strong in the language, and it was like, it's a big deal, and it was there in the beginning. So we can't just say, okay, it's something we learn later, but we have to live with it from day one. And that's something, but it also helps us understand what we do. So it's not only bad, it's actually one of the strong points and one of the advantages. Yeah. So that's that. And sometimes we have a little bit of a problem when we integrate like Java libraries or whatever, that we kind of have to build these bridges. But most of the time we can just use this, and we should really be accurate with the type system. And that's important. And there's not this exception like with array of list and list of array or whatever, that doesn't work. So everything works. But one thing that we are just seeing now, akka was kind of untyped, and we have to live with that when we use akka, that it's like that, but it's moving to typed akka now. One thing is very challenging also. Maybe it's good, maybe it's bad, but the types are mostly implicit. Yeah? We write something, and then the compiler figures out at compile time what type that is, and so it's exactly equivalent like writing it there. But when we are new to Scala, then we see, oh, what type is this? And it is for, if you're advanced, of course, it's faster because you have less to read and less to write, and it's clear. But if it's not clear, I think it's totally okay to write it in there. Yeah, and there's just okay, you find out what type is it, colon the type, and then you can read it. It doesn't make it worse, it doesn't make it better. But if your level is that you have a lot of places where you have type information which you don't easily figure out, I think it's okay to write it there. And if it's like trivial, it's okay to remove it there, but because the code should be readable, not only writable for the person who happened to do it. So in the end of the day, we have to embrace it, and we have to live with it, and we have to invest time, because it's something that we can't delay. We have to deal with it in the beginning. So the next thing, when we write the trivial hello world program, we don't need the loop, but then the next program is a for loop where we print the squares of 1 to 10 or whatever, and then, oh, wow, where's this thing? And well, the point is, of course, we want to do functional programming, and when we do functional programming, then we have to think about some things. So there's one thing that is a little bit shaky. The normal for loop mutates the loop variable. And yeah, we can, but we shouldn't. Usually the default is not to mutate, so we should kind of try to avoid it if we can easily. And the other thing is, these for loops, they exist only for the side effect. We do for something, and when we do something, and then this do something is side effect. And we want to move functional programming, so side effects are something that usually we don't want. Of course, sometimes we need them, and sometimes we use them, but we want to make it the exception. So this whole nice for loop that is kind of the basic building block of most programming languages suddenly doesn't work as a default. It's kind of only as an exception, maybe. So we have to deal with it. And how do we deal with it? So we have the world of for comprehensions. And that is basically just another way to write things like map and flat map. So basically what we do and what we can do and should do and what is like a way to work is we have collections, and then we run functions on these collections with map and flat map. And then we get other collections. A collection can be also this 0 to 1 type of collection, like option or something like that. But that's how we work. And for is just a way to write these things in another way. And so it's powerful, it's useful, but it's basically syntactical sugar for something else. And it has a return value. Everything without a return value is suspicious, because that does nothing. Yeah. So there we have a return value, so we are in good path. So that's the thing. And something else that is of course possible and that we do here, the loop variable is kind of a local variable to the loop body, so we are also safe here. And so it's actually possible to go there. So the thing is, you should embrace it, but you can make a team decision. You can say, okay, we like to write everything with map and flat map, or we like to write certain things with for. It's more or less a decision what you in the team liked better. Yeah? So next thing that we sometimes encounter is this issue with break and continue. Break is very useful. I think it was like, wow, when I had like moved from Pascal to C, and Pascal really, and C, oh, you had this break, and you could really do the things that you wanted. Yeah, you do a while, and then you do something, and then you knew in the middle the condition. In the middle of the loop, you could break out when it was fulfilled and then do something else. And it was like you could write what you want and not just something ugly. So, yeah, and now this continue you can discuss if you need it, but the break was really cool, especially that you could break out of many loops at one time. But, yeah, what's there? It's not there. So, missing in Scala, and it was so good in Java and C. So what do we do with it? There is a replacement, and it's called breaks, and we just have to adapt to it, and you create these breaks, and then within that you can use break, and you can basically do it. So it's just a little bit different way to write it, but in the end you can get the benefits. Okay, so the big issue is this immutability. And we already heard, depending on what talks you were and what talks I were, but immutability is of course something and is a little bit religious to say, okay, immutable, everything has to be immutable. And is this going? No. But in the end, it is a useful tool because things that are immutable, we can pass around as much as we want. And nothing can go wrong. Because when we pass things around that are somehow mutable, then somebody will mutate them, unless we are a very good team. And then somebody else will use it, and we get all kinds of funny effects. And even if you know Java, you had this fake immutability. Yeah, you had like, you created a list, and then you put the list into an unmodifiable list. But that's like you put something in a box, and you give the box, but you don't give the key, yeah? And then the people think it's safe, but you still have the key. And so the guy who gives out the unmodifiable thing can still mutate it, and maybe doesn't think that it's bad. So it's much better, because we really have serious immutability, and that gives us a serious advantage, because we can really pass things around in as many threads as we want, and it's just working. So the question is if we can just go and say, okay, this is a hard one, yeah, because we just program and we assign things and we change things, and then especially collections, we add something and we put something in and out and whatever. It's our programming world when we come from Java or PHP or Perl, and now suddenly everything that we do is forbidden, yeah, because suddenly, oh, you add an element, you have to make a new list. Everything breaks. So it's really bad. And we can say, okay, we don't care, we just put was and we use mutable collections, and we can perfectly well program, but then we don't move the Scala way. So it's something that we should, okay, use it for the first year to get into Scala, but really have the goal to move away from that and move to real stuff, and better just try to be there in the first day. So what Scala does, it encourages immutability, so the default is val, and var is kind of the exception, even though it's not longer, and the default is immutable collections, and live with that. That's really the thing. But yeah, it's really sometimes you think, oh, I can't program anymore. But yeah, people can program. It's possible. And sometimes it's a good idea to do recursion. And then you say, okay, I just write everything with recursion, and then I get a new instance of everything in each loop level, and then I'm fine. And there is something with recursion that we need to remember. And that is, we can do some kind of recursion that blows our stack. Yeah, we test it, it works. We test it on the development system, we test it in unit tests on test system, everything works. And then we put it in production, it also works. And then in the end of the year, there's this real big processing job. And there we get the Stack Overflow. Yeah, so that's something that we need to worry. And well, in Java it's not better. In Java we get the multi-threading exception. That doesn't occur otherwise, but when you have really heavy load, then suddenly the threads step on each other and mutate each other's state, and that somehow goes wrong. So anyway, it is very important to consider this tail recursion. So when the last thing in your loop, in your body, is the call to the next one level, then you have a tail recursion, and then when you mark it as tail recursive, the compiler can figure it out and actually makes it into a loop. And that is also something that is very hard, because the natural things we write recursion just don't go that way. They just create stack overflows. So that's this thing. But yeah, it's really interesting, and we learn a lot when we consider this, and yeah, it's possible. Then what we do get is we get pure functions. So it is like when you have mathematics, your function is something like sine, yeah? And the sine of pi is always 0. And when you do sine of pi another time, is also 0. So that is a function in mathematics, and we want the function of mathematics to be the same here. And so if there is no variable, no state, no side effect, nothing happening, then of course it can't be a different value different times. So it helps us for that if we have every thing immutable. And also, as I said, with multi-threading. But we shouldn't be religious, so we have to get our job done. And when we say, okay, I followed all these rules, and I had a calculation which should finish an hour, but it takes a year, but I can prove that it's correct. Okay, but won't help us. We usually need to get certain things done in certain time. And there is simply cases where we can't get things done in the time. I mean, not the time to program, but in the time to do the calculation, because sometimes we can get more efficient algorithms if we use mutability. But that is okay. We can think of this. This is a city, yeah? And you have roads, and you have certain rules how you use them. And when you are on the public roads, you have to follow all the rules, and if everybody did that more perfectly than we humans can, then probably would be no accidents, yeah? But of course we can have our garden, and in our garden we can do whatever we want, yeah? We can drive on the left side, we can use something bigger and whatever, but whatever goes outside of the garden has to follow the rules. So we can write a function that internally does certain things, but it behaves externally perfectly according to the rules. And that way it's possible to use something. And of course, when you're advanced Scala developer, you sometimes have to do that, because you have to get hard things done. So it's not a religion, but it's a tool to help us build big systems that safely work together. So this is really a hard one, but we embrace it and we learn to live with it, and we really get a lot of profit. And we should use mutability wisely and very little. But it's okay if we know what we're doing. Next one, null. Yeah, we can just use null. But it's bad, maybe. It's just like Java, of course, and we can just use it. But yeah, why it's not recommended? It caused a lot of problems. So the most serious problem, we get this null pointer exception, and sorry, we get it, yeah? It's just we forget one place, and then we get null pointer exception anyway. And it's kind of breaking the idea of the type system. So yeah, we don't need it. We should use this option thing, and with option we can express basically the same things, but it's just cleaner and more controlled and more beautiful and more safe and everything, yeah? And of course we only need the null when we integrate legacy code. We have some Java library and that doesn't know option. Okay. Then one thing that we should consider is when we use option, we could just write the same code as with null, that we do this if stuff, and then we test, is it like the none case, and then we just don't gain very much. We gain a little bit, but we should really try to use option with map and flat map, and with the Scala ways, and each case that we don't need is better, because usually if we can write some code that covers all cases, I think that's cleaner. And with option we get a lot of chances to do that. So yeah. So option, I think, is not really so hard. So it's I would really very early recommend to use it. Next thing is exceptions. Exceptions is like null. We can just use the exceptions the way that we use them in Java. It's no problem, they work, everything is fine. And there is this alternative try. So why should we consider this try? There is this issue that we have when we nest try with option and future, then it gets ugly. So one of these levels is okay, but then we have to try that we untangle it and that we don't get like deep nesting of future, of try, of option, of try, of what something that becomes ugly. So this is something that we need to embrace when we work with the capital try. But yeah, it's possible and it's good. So the problem is exceptions are kind of side effects, yeah? We have a function and it returns something. But then suddenly, no, it doesn't go there. It goes totally different path. And there we don't know about that. They had this idea in Java to declare it throws this exception, but it proved to be a failure because no other language does it. And when you do like functions and pass functions around and then functions of higher order functions and whatever, then this becomes simply unhandleable, and Java is also kind of moving away from it for the sake of the Java 8 lambdas. They had to wrap exceptions in their own libraries to do that. So this is not really cutting it. And then when we have function result and the function returns integer, but throws some kind of exception, and then we use it as a the return value as a parameter input for another function, yeah, and then we say integer and it can throw exception this and this. We don't write that, but yeah, actually that's what we do write, because the try is exactly that. We say it is this normal return value, and if we are not normal, is this kind of exception. And then we actually have exactly what we mean, but in a clean way, not with this throws that is kind of special. So it's really nicer. It's a little bit work, but it's not really a big deal because it's basically the same, just written in another way. And it's really nicer because we really are working with a type system. And so we can say the exceptions, normal exceptions, are evil. And yeah, it's like a second return type. Okay, but again, we can say there's certain places where exceptions are okay. One thing is when we really have something that goes heavily wrong and we say, okay, the program is broken and we just can't fix it. Okay, then we throw the exception and then we restart the program or we fix it or whatever. But then we really have something where we can't say, okay, we just invent a value. We can't. It's bad, but it's as bad as it is. We can't fix it like by imposing a rule, because the problem that we have will in some way surface. And the other thing is, again, this garden. We can write a function And within our function, we can throw exceptions and catch and whatever we like. But keep it in the garden. There's the fence around the garden, and don't let the exception be thrown over the fence. That's totally okay. That's this issue. So, next thing that is really a hard one, fortunately not in the first week maybe, but that is this issue of futures at async. So, why? I think when we want to do Scala, there's certain things that we profit. We can say, okay, we get operator overloading. That's already good enough. But yeah, we get better multi-threading facilities. And then in some point of time, we encounter futures, we encounter asynchronous operations and these things. And we should encounter them because then we make profit of what we went through in the previous slides, yeah? So that's something that is hard because kind of we could think like there's one single flow of code and we go that flow and that's it, and now suddenly we have to deal that we let certain things run and we don't know when they finish, and then in some point of time we have to collect all these things together, and it's just in terms of thinking already a challenge, yeah? And also we have the laziness. It's just another aspect of the same thing, and it's very powerful, and it gives us a lot of performance because we calculate things just in time, yeah? There was somebody who told, like he told his daughter, clean up your room, and of course she didn't. And then he said, okay, now I look, and then she cleaned up the room. And this daughter was very efficient, even with 3 years, and we should learn from the 3-year-old and gain the efficiency. So certain things that we maybe don't have to do at all, yeah, we should do just in time. So laziness is that, and there is things where we can say, okay, it's just a gain in efficiency, but there is things where we can do something with it that is just otherwise impossible. We can create an infinite list. And if we just create it non-lazily, we don't create it, it doesn't work. But it's sometimes useful because then we can say, okay, we don't know how much we use of this list. And we extract whatever we need from the list in order to do certain things. And that is very elegant with lazy operations. And therefore, yes, it's good to embrace these things. Of course, there's always other ways to do it, but it's much more beautiful this way. And we can write like this number of line of code and not like, I don't know how much, yeah? So, it's something that in functional programming we should embrace and we should live with because it's the benefit and we want to make use of it. So yeah, I can't give the answers to it, but I would recommend to really go into it and play with it and get experience with that. So yes, it's the bonus, one of the bonuses. Yeah. There's some minor thing again, that's this implicit. It's not really that bad, but we have like implicit parameters, implicit classes, implicit conversions. And yeah, the question is why? Anybody in Ruby, you have something like monkey patching. And it was really, when you write, for example, a library and it contains a new numeric type. And now you like this operator overloading, and you want to add this thing with an integer. Then you have to teach the integer how to add your new numeric type, and you can't change the library. But in Ruby, you could just open an existing library class and add a method to it. And then it worked, and it's really nice. It's very powerful. But if you have like a big landscape of libraries and then at some point of time you get contradictionary entries there, and then you get very ugly errors. So they wanted something like this in Scala as well, but they didn't want it as fragile like as in Ruby. So what you have implicit conversions defined, and then you have this integer, and then in this context you convert the integer to something that you own, and that is possible to add to your new numeric type. And then it behaves as it should and as you want, and is very elegant. So yes, it's just an example, and so this thing is really powerful, and it's good, but it is hard for us because it does kind of things under the table. And usually we read our code and everything works like straight ahead, and suddenly we have something that we don't understand, and it's really hard to search it. But yeah, it's needed in many APIs, so we can't avoid it, and it is really powerful. So at least we need to learn to live with it when we use somebody else's APIs, and like APIs in Akka and whatever they are like that. So that's unavoidable, but it's also powerful, and for certain things you can just very elegantly write them there. So I think it's a bonus also for us. Yeah, now comes the next thing. That's the database, which is kind of every application. Of course, it's forbidden because database is kind of a side effect always, so we can just skip this part. But in the end, program totally without side effect is totally without use. So in the end, we do need some kind of side effect, because otherwise we don't need to run the program because it doesn't do anything. So the database is there, and we need to use it, and we have ways to wrap it, that we say, okay, there is this database code, and of course it has side effects on the database, and that's okay. And then we come as Java guys, and we are used to Hibernate and JPA. Who likes Hibernate? Who hates Hibernate? Okay, so sorry. So I think Hibernate is actually incorrect, so conceptually. And it has bugs, so bugs are there, and it's okay. Every software might have bugs, and Hibernate does, but it's conceptually an issue, because we have like this issue. We have the SQL database that is transactional, and then we do caching, and we have like object trees, and we don't know to where we handle them in the cache. And then we have transactions in the database happening, and then in the cache there's something else, and it is something that is very hard to control, and I'm pretty convinced you can construct cases where you can prove that it's incorrect. Which doesn't mean that you can't do good stuff with it, and you can do useful programs with it, and it's helpful and whatever. It's more a theoretical question, but of course it will bite you at some point of time if you have very complex things. So I am very happy that they didn't try to write like in the standard Scala stack something like Hibernate, but they went a different way. So it's Slick. And Slick is, I think it's very nice, but it's much more low level than Hibernate. It's much less abstraction. So Slick actually is a way to create SQL queries, and is more or less like embedded SQL or JDBC, but does that more nicely. But you can write like Scala code, and then it creates the query. But it actually creates a query and runs the query. And it's something that we can understand and control, and it's like what databases do. You create a query, you run the query, and then you get a response. That's something that's perfectly supported by typical databases. So it's something that we have under control. That's correct, and I think it's good to use it and to work with it. And in the end, we maybe can do like have to do a little bit more work because we have to write things ourselves. But in the end, when we think about Hibernate, yeah, of course, it was like very fast to write these things. But then in the end, how many weeks did we spend to get this special edge case working where it did something that we didn't understand? So it's a change, and it's more low level, it's less comfortable, but in the end, I think it's okay. And actually, I think it's the right way and the preferred way to go. Yeah, maybe I was a little bit fast, but I think we are tired enough. So I would say it's already time for questions. Yeah, please.
Do you see me? It's more like a remark, not a question.
Okay.
I have a note here that when you say that breaks are okay, or that mutability is okay because you need to get things done faster, or that this try option future looks bad. So quite often that means that something's wrong with your program, that you should plan it and design it in a better way. And if you simply say that it's okay that you can write things this way, then you not only let that wrong part of the program still be there, but you add new bad code, that wrong part.
You're right, yes. You're totally right. And you shouldn't just say, okay, I try something for 10 minutes and it didn't work, and then I fall back to something that is bad, but okay. You're totally right. You should try very hard. That's one thing. I totally agree. And the other thing about getting things done in terms of mutability, it was maybe a misunderstanding. You have two aspects of it. Okay, you have a team and you have a boss who tells you you need to finish by this date. Okay, then you finish like 2 months later and everybody is happy. And maybe you get 3 months or so and then you get something really good and you should do that, okay. But the other thing is you need to write a program that is performing well enough. And there are certain kind of problems that are very hard to get performant with immutability all the way through. They are very rare because normally for something like sorting, we use libraries. It's not our problem. But if we want to write sorting algorithms, I think it's a good idea to have like a garden for the sorting algorithm, and there we use mutable structures, but then we give away immutable as a result. Okay? Yeah, please.
Please tell me your opinion about macros.
About?
About macros. Scala macros.
Scala? Macros. Yes. I think it is a little bit of an overkill. I think the language of Scala is so powerful, and it is going one step too far for application code. And I think when you write like framework code, when you write very special libraries, you can encounter situations where you really try hard and you say, okay, I really profit from the macro. But it's something that I would think is an overkill and is kind of wrong direction most of the time. Yeah.
So you mentioned that breaks. I never heard of the breaks thing, so I'm not sure how is it working, but isn't it similar to exceptions, as it breaks the flow of your code?
Yes, that's a very good point. But the point is here, we keep it in the garden. We have our garden and we fence it with a breaks block. And then inside the fence, we are allowed to do pretty much whatever we like. if the fence is strong enough. And that's what it does. Yep.
Thank you very much for your talk. And I do have one question about the return keyword and its usage in Scala, because one of those upon time my team criticized me on the one pull request that I'm using for the just one case return keyword explicitly in my Scala keyword in my Scala code, but he did not explain why, to be honest. And what's your opinion about the usage of return explicitly? In what cases it's allowed to do, and in what cases it's preferred not to, or preferred to avoid? Thanks.
So, first of all, I think the return keyword is kind of not used most of the time, because return is something that we always do, and we always return the last thing of the block. And therefore, if we write it without return, we are on the right track. And yeah. But yeah, you can use it, of course.
Hello.
Yeah.
I just actually wanted to add something on the return return keyword thing, which is actually significantly more complex than that, because in Scala, certain control flows, if you return from inside a closure, for example, it doesn't just return like you would do in Java. It is actually throwing exceptions to break out of the inner blocks. So it's a bit of a mess and is generally frowned upon. What I would generally say is, in that point, you probably want to think about refactoring your code into smaller sub-methods that you can call in a in a different way.
I agree. Yes, it's kind of like break and like throwing exceptions and whatever, and all these things that give us a lot of power, but that are extremely dangerous, and we should learn to get away from.